So, welcome. So, today we will continue our discussion about the limit, and let us recall what is the formal definition of limit. So, we say f is a function, and we say that limit f of x goes to a is equal to L if for every epsilon given any epsilon, that means if we had been provided with an epsilon, then for that epsilon there will exist a delta which is positive, such that f will be taking value close to L, that means mod of f of x minus of L is less than epsilon whenever mod of x minus of a is less than delta. We may just uh, agree not to include the point a, except at the interval a minus delta to a plus delta, all those values f will take, that will be close to L, and this close as we want means this close we are determining how close we want, whatever the closeness given any epsilon positive, however small it is, we can always find a delta. If we can find a delta, then we say that limit f of x goes to a is equal to L. So, that what we say that this is essentially that if x belongs to a minus delta to a plus delta, accepting the point a, then f of x should belongs to the interval L minus epsilon to L plus epsilon. That is what we had defined in the last lecture. Now, let us do some example. So, first example is f of x is equal to x square minus of 1 by x minus 1. If x is not equal to 1, you see at x equal to 1 the denominator is 0 for this function. So, we are here what we are defining f of x for x not equal to 1, and we give one value 0, which is if x is equal to 1. This is certainly a function. So, now we are interested, suppose we want to find the limit as of f of x as x goes to 1. So, then you see in our definition is that we say that limit f of x goes to a equal to L if something happens. That means, if we are asked to find the limit, then we need to guess that what our L should be. So, in this case it is easy to guess that L should be equal to 2. So, now after we have done this guess, now we want to prove rigorously that limit f of x goes to 1 is actually equal to 2. So, for that what we need to do? We will take epsilon positive. For every epsilon we want to find a delta. Now, we start with a epsilon positive, choose a delta positive which is less than epsilon. So, in this case what happens, if x is not equal to 1, then you look at mod of f of x minus of 2, which is equal to mod of x square minus 1 by x minus 1, and x is not equal to 1. So, factorizing we are going to get this is x plus 1 minus of 2, which is mod of x minus of 1, and we are interested to find the limit as x goes to 1. So, we are looking at the interval some 1 minus delta to 1 plus delta, our delta, such that this is. So, now if this is less than delta, and if we choose our delta to be any delta positive which is less than epsilon, then we will get that limit f of x goes to 1 is equal to 2. Now, let us do another example. This is where it is been given to us that so that limit x goes to 4. square root of 2x plus 1 is equal to 3. So, here we do not have to make a guesswork, it is given that we need to prove that this is equal to limit is equal to 3. Now, first let us observe that square root of 2x plus 1 minus of 3 modulus, we want to make it as small as we want. So, this is if we do, then a square minus b square by, if we multiply and divide by square root of 2x plus 1 plus 3. Remember that we are interested in all those x which are close to 4. Therefore, in this case the denominator is not going to be 0, and we are always taking the square root means unless and until mentioned. So, we are taking the positive square root, non-negative square root. So, now this 2x plus 1 minus 9 by square root of 2x plus 3. So, which is simple arithmetic will tell us that this is mod of 2 into mod of x minus of 4 by square root of 2x plus 1 plus 3. Now, take epsilon positive. Now, suppose we are looking for a delta. Now, if our delta is strictly less than 1, because we are just want a delta to be positive. Now, we take our delta, let us say that delta is less than 1, then what is the delta we can choose? Now, for this we want to look at the interval 4 minus delta to 4 plus delta, that means mod of x minus of 4 is less than delta, which is less than 1. Now, therefore, this x minus 4 is less than 1, greater than minus of 1. We have 3 is less than x, which is less than 5. Therefore, square root of 2x plus 1 minus of 3 modulus is equal to what we have seen is 2 into square root of mod of x minus of 4 by square root of 2x plus 1 plus 3. Now, this is strictly less than, this quantity is less than delta. So, this numerator is less than 2 delta. Now, if x is greater than 3, then the 2x plus 1 is greater than 7, 1 upon 2x plus 1 would be less than 1 upon square root of 7. So, this quantity is less than 2 delta divided by square root of 7 plus 3. Now, this delta we want to show that this is less than epsilon, this is what we want to show. Now, if we choose our delta already less than 1, so which means this is what we are getting. So, if we choose our delta to be the minimum of 1 square root of 7 plus 3 by epsilon by 2, then this is what we are going to get, that this is less than epsilon. Okay, so, now what are the properties of limit? Now, it can happen that I mean one would like to see that suppose we are given with a function f. Now, we are interested in limit x goes to a f of x. Now, obviously, intuitively we see we can see that this limit is going to be one number. It f, that means f cannot approach to two different limits. So, that is what we would like to prove. If limit f of x goes to a exists, then it is unique. So, suppose not, therefore, suppose limit f of x goes to a is equal to L and limit f of x goes to a is equal to m. Then what do you want to show? L is equal to m. So, now if we can show that for given any epsilon you give me mod of L minus of m is less than epsilon, then L is equal to m. Suppose somebody gives us 1 by 10, L minus m is less than 1 by 10. Somebody gives us 1 by 10 to the power 5, we will also show that L minus of m is less than 10 to the power 5. Similarly, any small epsilon, if L minus of m is less than, modulus of that is less than epsilon, then L has to be equal to m. There is no other point, because if L is bigger than m, then L minus of m will be bigger than some positive number. Now, for epsilon working for any positive number less than L minus of n, we will get a contradiction. Therefore, this has to be equal to 0. Okay. So, now for a given epsilon, what we have, there will exist delta 1 and delta 2 such that mod of f x minus L is less than epsilon by 2 whenever 0 is strictly less than x minus of a is less than delta 1. Similarly, we can get it because I am sorry, this is f of x minus of m, this is less than epsilon by 2 whenever x lies between a minus delta to a plus delta. So, in this case, this is f. If I take delta to be minimum of delta 1 delta 2, then what we see is that mod of, and we take mod of x minus of a is less than delta, then this will imply that mod of x minus of a is less than delta 1. This will imply that f of x minus of L is less than epsilon. Similarly, if mod of x minus of a is less than delta, we will get that this is less than delta 2 because delta is minimum of delta 1 and delta 2. This will imply that mod of f of x minus of m is less than epsilon by 2. Thus, we have okay. So, we have now mod of L minus of m, this is lesser equal to, by triangle inequality, mod of f of x minus of L plus mod of f of x minus of m, because mod of L minus of m, mod L minus m, this is equal to mod L minus f of x plus f of x minus of m. Now, you apply the triangle inequality, you get this. Now, this is less than epsilon. Okay. So, this is what the proof is. Okay. So, now, this is if f and g both are functions, then we have seen that f plus g is a function, f g is a function, any scalar times f is a function, and f by g wherever it is defined, that is going to be a function, mod f is also a function. So, now what happens to the limit? So, if f of x, x goes to a is equal to L and g of x, x goes to a is equal to m. Let us take C any real number, then in that case what one will get, that f of x plus g of x, limit x goes to a, f plus g as a function which is equal to f of x plus g of x and x goes to a, this is going to be equal to limit of f plus limit of g, which is L plus m. Similarly, what we are going to get, that if f g of x we take the limit, then this is going to be L m, and some scalar times f, this is the function C f, C f at x is equal to C times L, and if m is not equal to 0, limit of g x, x goes to a is not equal to 0, which is equal to m, then f x by g x, this is going to be L minus of m, and mod of f of x is limit x goes to a is mod L. So, this is what it is expected. So, now I will give you the proof of only one, and I request you to carry out the proof of the other 4 properties. That will be fun. Okay, so this is what we now try to prove, that limit x goes to a, f plus g x is equal to L plus M. Now, that means what we want to get for every epsilon positive given any epsilon, we must find a delta such that mod of x minus of a is less than delta should be f of f plus g x minus L plus M should be less than epsilon. Okay. So, now limit of f of x, x goes to a is equal to L. So, for that epsilon, for a given epsilon, there will exist a delta 1 such that mod of x minus of a is less than delta 1 is going to imply f of x minus of L is less than epsilon by 2. For given any epsilon, I can find a delta. So, for epsilon by 2 is also a positive number, we will find a delta 1 for that. Similarly, we will find a delta 2 for g mod of x minus of a. Remember that this is what all the time we say, that 0 is less than this. This will imply mod of g x minus of m is less than epsilon by 2. Now, we take the delta to be minimum of this delta 1 and delta 2. Now, in this case, mod of x minus of a is less than delta, then what happens? Now, we look at f of x plus g x minus L plus M, which would be lesser equal to f of x minus of L plus g of x minus of M. Now, x minus of a is less than delta, that means delta is less than delta 1. Therefore, x minus of a is less than delta 1. This will imply that f of x minus of L is less than epsilon by 2. Similarly, x minus of a less than delta will imply x minus of a is less than delta 2. Therefore, g x minus of m is also less than epsilon by 2. So, this sum is less than epsilon by 2 plus epsilon by 2, which is equal to epsilon. So, similarly, you try with CF and FG and f by g and modulus of f. Okay. Some of the more properties of the limit. This limit, what it says is that it respects the inequality, in the sense that let f of x is lesser equal to g x in the interval containing a is here and this is some a minus r, a plus s, whatever it is, this is the interval where f of x is lesser equal to g x except possibly x equal to a. Now, if limit of f of x equal to L and limit of g x is equal to m, you see f of x is going to approach to L whenever we go close to a. G of x is going to approach to m as we approach x approach a. Therefore, what it says is that then the L should be lesser equal to m, because f of x is lesser equal to g x. That is quite expected. So, how does one prove this? So, suppose let us take L is bigger than m, because what we want to prove that L is lesser equal to m. Suppose L is greater than m, then we must arrive at a contradiction. Now, for every epsilon positive, we have delta 1 delta 2 such that x minus of a less than delta 1 will imply mod f x minus L is less than epsilon by 2, and x minus of a less than delta 2 will imply g x minus of m is less than epsilon by 2. Now, again the same thing, we take the minimum of delta 1 delta 2. So, here for g I have this is x minus delta 1, this is x plus delta 1, delta 2 is here, let us say, and we are taking delta to be the minimum of this, that means x minus of delta is this. Now, for x minus of delta less x minus of a less than delta, what we have is that now from this two equation. So, because then in that case x minus of a is less than delta 1 as well as x minus of a is less than delta 2. Therefore, f x minus of L is less than epsilon by 2 and greater than minus of epsilon by 2. G of x minus of m is less than epsilon by 2 and greater than minus of epsilon by 2. Therefore, g x minus f x minus m minus L, if I subtract this, then this is going to be less than g x minus m is less than delta, and f x minus of L is greater than minus of delta by epsilon by 2. Therefore, minus of this is going to be less than epsilon by 2. So, epsilon by 2 plus epsilon by 2, which is epsilon. Similarly, this is going to be bigger than minus of epsilon. So, that is what the proof is, x minus of a is less than delta. Okay. So, now for the time being, let us what we have assumed, we want to get a contradiction. So, now take epsilon to be L minus of m. We have assumed that L is bigger than m. Therefore, this is the epsilon which is positive. Therefore, in this case, what do we get? Suppose this is less than epsilon is L minus of n. Therefore, g x minus of f of x is less than epsilon plus m minus of L, and we have taken this to be epsilon. Therefore, this is going to be less than 0. So, what we get is that f of x is less or equal to g x is given, but here what we are getting is that the g x is strictly less than f of x, which is a contradiction. Therefore, L has to be lesser equal to m. Okay. So, now what we have seen is that the limit of a function is unique. Now, if f of x is lesser equal to g of x, then the limit of f of x is lesser equal to limit of g of x. Now, this is very powerful theorem, I mean useful. If f of x is lesser equal to g x is lesser equal to h x in some interval containing a. Now, if limit of f of x equal to L, limit of h of x is also equal to L, then this g does not have any other choice, but the limit of x goes to a of g of x has to be equal to L. It will g is already you have started that g is a sandwich between f and h. Now, in that case the limit is also going to be sandwiched, that is what is the. So, in order to find the limit of g of x, if we can show that this is dominated by a function and which dominates another function, and both this left and right side function they goes to the same limit, then the in between has no other choice but to go to the same limit. So, now the proof is that you take epsilon positive and then you have delta 1 and delta 2 greater than 0, such that mod of x minus of a is less than delta 1 will imply f of x minus L is less than L. Similarly, what you get is that for h you get the delta 2 h of x minus of L, this is less than epsilon. Now, you take again delta to be minimum of delta 1 and delta 2. Now, for x minus of a less than delta would be x minus of a is less than delta 1, x minus of a is less than delta 2. So, in that case, so f x minus of, so here what you are getting is that the L minus of epsilon, this is less than f of x from here, which is lesser equal to g of x is given, which is lesser equal to h of x given, and which is less than L plus epsilon by this. So, therefore, g x is greater than L minus of epsilon is less than L plus epsilon for a given epsilon whenever our x is in this delta. So, we have for epsilon we have found a delta, this happens. So, limit of g of x, x goes to a is nothing but L again. Let us see some very usefulness and example for this sandwich theorem. So, what we get that if limit of mod of f of x, x goes to a is equal to 0, then f of x, x goes to a is equal to 0. As we know that mod of x is equal to 0 means x, if and only if x is equal to 0, that is limit also kind of satisfy this property. That means, here I am taking that limit of x goes to a, f of x modulus is also equal to 0, then I will get this. So, this is very if you take the sandwich theorem, you have f of x which is greater or equal to negative of mod f x and lesser equal to f of x, mod of f of x. Therefore, this goes to 0, this goes to 0, therefore, there is no other choice, f of x is going to be 0. Similarly, let us try to find, this is a very interesting example, x sin 1 upon x. So, if we take this is modulus which is definitely greater or equal to 0. Now, which is less than mod x, because every sign whatever the value the sign takes, so that is going to be lesser or equal to 1, and here when we are talking about x tends to 0, we do not have to worry about x is equal to 0. So, sin 1 upon x is a very well defined thing for x not equal to 0, and for the limit purpose we do not need to consider what is the value of the function at that point. So, we do not have any problem in having sin 1 upon x. So, that is lesser equal to 1. So, which is lesser equal to mod x, and now you can see that this goes to 0 and this is greater or equal to 0. So, this is 0. Now, similarly we can do it. Suppose we have an arbitrary function which is 2 minus of x square, f of x is greater or equal to that, and which is dominated by 2 cos x, which means cos graph is going like this, and 2 minus of x square is a graph like this. So, now if any function which is dominated by these two function, and when x goes to 0, this goes to 2 and this also goes to 2. Therefore, limit f of x, x goes to 0 is equal to 2. Okay, thank you for your attention. So, we will continue other properties of the limit the next lecture.